Remote sensing is the process of collecting information about the surface of the Earth from a distance. So one of the most rapidly evolving platforms in remote sensing are UAVs, or unmanned aerial vehicles. We have been applying UAV technology to different areas. For example, for wetland delineation, and everyone knows wetland is a pretty important for urban settings. And you typically can call wetland is the purification system for any urban environment. And so we recently developed a strategy and mechanism how to use the UAV to detect and delineate the wetlands. The UAV can fly about 400 feet above the ground and apply multispectral sensor and combining with thermal cameras. And those sensors basically can detect a lot of things human eyes cannot see and to delineate the wetland precisely and timely.
So one of our remote sensing applications that utilizes UAVs is the detection of soil moisture. And soil moisture is a predominant factor in nearly all atmospheric and hydrologic processes. And with good soil moisture data, you can better predict things like conditions for extreme floods, extent of droughts, agricultural productivity, even things like the transport of vector-borne diseases.
Assume a land is like a sponge. If the sponge is saturated with the water, and then obviously the sponge will not hold any additional water, and the water, whatever is dropped on the sponge, will be generated into the overland runoff. That means typically, sometimes we call flood water. But if the sponge is dry enough, so any water coming from the sky will be soaked in. So it's gonna take a while and retain those water in the sponge. So you're gonna have a less chance or less risk to have a flood.
So most of our soil moisture data come from either satellites with resolutions measured on the order of square kilometers, or ground observations, which in general are very fixed and limited in their locations. So using UAVs as a thermal and optical remote sensing platform, we've been able to bridge the gap between satellites and ground observations to a scale that's much more usable for watershed management. Now, of course, you can also do this with manned aircraft, and in fact, that's common practice. But the advantage with UAVs is that you can deploy them daily at a moment's notice to get very repeatable results at a fraction of the cost.
So water actually being used for many different purposes, for residential, commercial, and even the one area here is for golf course. The purpose of watering a golf course is really not so much about to maintain appearance, but actually to keep it healthy and playable. Using UAV, we are able to measure the distribution of total water availability at the root zone, which allows the superintendents to program irrigation system more efficiently.
So these remote sensing techniques rely on the principle that objects reflect and absorb light differently depending on their physical and chemical properties. So if you recall the electromagnetic spectrum, which starts with gamma rays at the shortest extreme and then radio waves at the other, somewhere in the middle is visible light, which is what our eyes can perceive. So the multi and hyperspectral sensors on these UAVs can measure a wider range of frequencies that our eyes fail to detect, such as infrared and thermal.
So reservoirs and the water bodies in urban settings are the major resources for water supply. The water evaporation from the lake is a reduction from a water resource. So in the past, no one cannot really detect those water evaporation factor easily. So we recently developed the lake evaporation monitoring program using UAV for several lakes in Dallas-Fort Worth area to assist local water authorities and water districts to better manage and better quantify their existing resources.